This is my comparator circuit. When I turn the potentiometer, I'm able to turn the LED on and off when it passes the compared voltage. Hi, this is Jacob Ayres, and this is my lab report for ENME 351 Lab 8. So the first exercise, I had to find the voltage output from a non-inverting op-amp circuit. So I solved this using nodal analysis. I picked the node in between R1 and R2, and I set up my equations and I solved, and I found that the voltage output is equal to the voltage input times the quotient of R1 plus R2 all divided by R1. After I found this, I built a non-inverting op-amp and I wired it all up, and so we can now look at it if I run the processing code. In a second, it'll come up. Alright, there we go. So, as you can see, as it is right now, the voltage out, which is the blue dot, is about 1.5 times the voltage input of which is the green dot. It would also be the white dot, but in this case, the white dot is being covered by the green dot because of just how the circuit was wired up. So yeah, as I change it, you can see it go up. So yeah, at 4 volts, it's at like 1.2. So one of the interesting things about this circuit is it really only follows the what would be expected of it over a fairly narrow range. I'm not entirely certain why, but it's probably just a characteristic of the the certain op-amp that that we're using, and it might have to do with the my resistor, the levels of my resistors. If they're not allowing enough current, it might be keeping it from working properly. I'm not entirely sure. This is my unity gain amplifier circuit. Now I'll run the code for the unitary op-amp. As the code starts up, once it starts, you'll see that V out and V negative will follow V in and V positive. This won't exactly be visible because of the fact that V negative is covering V out and V positive is covering the V in dots. So it'll follow it along between about a little under 5 volts and over about 1.8 volts. I'm not sure why it's at why the cutoff is 1.8 volts, but it could have something to do with the fact that we're not running it with positive 5 and negative 5 volts. Yeah, so that's that. This is my inverting op-amp circuit with a gain of -10. Now I'll show off my inverting op-amp with a gain of -10. In a moment, once the processing comes up, you'll be able to see that when I move the white dot, that the blue dot moves in the opposite direction a much greater amount, and it's centered around the 2.5 volt. It's centered around 2.5 volts. Here is my integrating op-amp circuit. The last op-amp circuit I built is the integrating circuit. So this circuit utilizes a capacitor and a resistor to find an integral of the V in. So as you can see, I did this math using nodal analysis again, and I get V out is equal to negative V in divided by RC. So here's my oscilloscope. As you can see, it's centered around 1.8. For some reason, that just seems to be a magic number with these op-amps. And so, as you can see, it integrates around that part, but it's inverted. Thanks very much for listening to my video, and have a great day.